Hello everyone, welcome to part 3 of the EQAO prep seminar videos. The question reads, select the expression that has a value that is the least. So this is an example of a question where we have to apply our power rules or our knowledge of fractions to solve every single option A, B, and C, and D in order to figure out what is the least value. We're going to start off with A. So here I have a fraction that I have to multiply by my numerator and a denominator that is inside brackets. So I want to, according to my BEDMAS laws, focus on solving the brackets first. The numerator has a power rule because there's one base and multiple exponents. So I have to actually keep the base the same and multiply my exponents before I can divide the powers. So that gives me an answer of 1 over 4 times 4 to the power of 6 divided by 4 to the power of 4. The rule for dividing powers, I have to keep the base the same and subtract my exponents. So I'm going to keep the base the same, subtract 6 minus 4. That gives me an answer of 4 to the power of 2 multiplied by 1 over 4. Now this is a situation where I have a fraction multiplied by a whole number. 4 squared is 16, but I want that to write the 16 over the number 1 to show that it's a whole number. When I reduce by multiplying, 4 goes into 16 4 times. So my final answer is 4 over 1, which is equivalent to 4. I'm going to go ahead and write that as the value for option 1. For option B, I actually have the power on the outside, but I also have 4 to the power of 3 divided by 4 to the power of 4 inside brackets. So using my BEDMAS rules again, I'm first going to solve for inside my brackets, the power division rule, which means subtracting the exponents. And then after that, I'm going to apply my power of 2. So I have 1/2. When I subtract 4 to the power of 3 minus 4, I'm going to get 4 to the power of a -1, which I then have to raise to the power of positive 2. Yeah, that gives me 1/2 times. The rule for negative exponents means we have to flip the base. 4 over 1 becomes 1 over 4. And I want to apply my power of a power rule, so I multiply that by the power of 2, or I could have applied the -1 times 2 as well. At the end, I would get the same answer. 1 over 4 raised to the power of positive 2 gives me 1 over 16. And I know when I multiply 1/2 times 1 over 16, numerators multiplied together is 1, denominators multiplied together gives me 32. So I'm going to go ahead and write that value down as my answer for B. So I'm going to look for a value that is less than 1 over 32 if that is possible. Okay. The next option we have to check is option C. So in this case, I have 1/2 that I'm multiplying by the expression inside the brackets. Just like before, I have the power of the power rule. So 4 to the power of 3 to the power of 2 translates into 4 to the power of 3 times 2, which is 4 to the power of 6, over 4 to the power of 4. So by now, I know I have to keep the base the same, subtract my exponents. Notice that I'm not skipping any steps. So that gives me 1/2 times 4 to the power of positive 2, which is going to give me a whole number. So I have 1/2 times 16 over 1. Now, reducing by multiplying and cross-multiplying, 2 goes into 16 8 times. So my final answer is 8, which is larger than everything that I have generated so far. So 8 is not going to be the correct answer. 4 is not going to be the correct answer. So B is the front runner right now, but we still have to check with D. Question D, the power is on the outside of the bracket, so I actually have to apply my power of a power rule to both the numerator and the denominator. So that means keeping the base the same and multiplying 4 to the power of 3 times the power of 2, and the same thing in the denominator, multiplying the power of 4 times 2. So that gives me 1 over 4 times 4 to the power of 6 over 4 to the power of 8. So that tells me I have to keep the base the same, subtract my exponents. So 1 over 4 times 4 to the power of negative 2. Now, just like before, I have to convert that negative power by flipping the base and changing it to the power of positive 2. Give me 1 over 4 times 1 over 4 squared, or 1 over 4 times 1 over 16. Now, when you multiply your numerators and multiply your denominators, 1 times 1 is 1, 4 times 16 is 64. And that 1 over 64, even though my denominator is larger, you have to understand the rule that the larger your denominator is, the smaller the value of the expression is. So our answer is actually going to be D. Okay. Now moving on to an algebra question. It's quite common in the EQAO. There are a total of 90 red and yellow tiles. Another way we can write that is red plus yellow is equal to 90. Okay, that is an algebraic expression that we've translated from the first sentence. There are 5 times as many red tiles as yellow tiles. So another way we can write that is our red tiles, red tile is actually equal to 5 times y, because there are 5 times as many red tiles as yellow tiles. So we have to take the yellow tiles and multiply it by 5. So the question is asking how many red tiles are there? Well, we cannot solve when we have 2 different variables, but what we can do is substitute the red tiles by something we know about red that is equivalent or has a y in it, which is our expression over here. Red is equal to 5y. So I'm going to replace r with 5y. Continue the rest of the equation. 5y plus y is equal to 90. So remember, y is the yellow tiles. So first I have to solve for the yellow tiles before I can figure out how many red tiles there are. 6y, because 5y plus y is the same as 5y plus 1y. 6y is equal to 90. But I'm not interested in 6y, I'm interested in y. So I have to take this number in front of the y and divide both sides by 6. So a little bit of division, 90 divided by 6 is 15. So I know for sure there are 15 yellow tiles, but if I went to circle 15, that would tell my teacher that I haven't read the question correctly because they're not asking about how many yellow tiles, they're asking how many red tiles there are. And I know that R is equal to 5 times Y. That means that R is equal to 5 times 15. So that tells me that the number of red tiles is 75 because 5 times 15 is 75. So again, the answer is D. Okay, moving on to the next question. We're back to linear relationships, and we can see we have three different graphs here that we have our different relationships, a table of values, an equation, and a graph. And we have to figure out which of the statements are true. So it makes the most sense when you have a question like this to try to identify the slope and the y-intercept where possible. Now for relation number 3, it's very simple because we have an equation. So I can see from the equation that my slope is equal to 3 over 5 and b is equal to 6. Now for the graph, I can see that we also have, remember the y-axis is where the y-intercept lies. So b is also equal to 6. But if I look at my rise over run, so I'm going to highlight two key points in the graph. And first of all, I know I have a negative slope, so it's not going to be the same slope as 3, as relation number 2, because I have to go down 1, 2, 3, 4, 5, and to the right by 1, 2, 3. So similar, but my slope is negative over here. My slope is actually equal to a rise over run. So negative 5 over positive 3. For relationship 3, I can calculate the slope. I can clearly see that there is no y-intercept here because I don't have a value of x is equal to 0. But if I take my first point and my second point in the table of values, and I want to label my first point 330 as x1, y1, and my second point, 625 as x2, y2. And I want to substitute that in my slope formula. So m is equal to y2 minus y1 over x2 minus x1. And that gives me a slope of negative 5 over 3, which is the same as relationship 1. So the graphs of relation 1 and 3 have the same slopes, but from what I have extrapolated from these three relationships, the relation 1 and 2 have the same y-intercept. And if we look at all these statements, you can clearly see that part A, or statement A, says that relation 1 and relation 3 have the same slope, while relation 2 and relation 3 have different y-intercepts. Well, if I look at relation 2 and relation 3, I would have to extrapolate this, maybe put this on find an equation y is equal to mx plus b, solve for b to figure out if that is true, but I'm going to give you time on your own. we have calculated that relation 1 and relation 3 have the same slope, but we might be able to find out the different y-intercepts by substituting into y is equal to mx plus b formula. So I'm going to leave that for you to do while we move on to the next question. A frame is in the shape of a rectangle. A second rectangular frame has triple the length and 1/3 of the width of the first frame. Complete this statement. The area of the second frame is a blank the area of the first frame. So let's let the length of the first frame be represented by L, and the width of the first frame be represented by W. And what we're going to do is use algebra to translate the statement. So a second rectangular frame, so we'll call this area 2, has triple the length, so that would be 3L. And we're going to be multiplying by a fraction as triple the length and 1/3 of the width. So I have to multiply this by 1/3. We can say 1/3 W, or we could say W over 3 of the first frame. Remember, L is the length of the first frame, W is the width of the first frame. Now, if I went to try to simplify this, you'll notice that the 3's cancel out. If we triple the length and take 1/3 of the width, that actually cancels out and we're left with length, the L, which represents the length of the first frame, and W, the same W that represents the width of the first frame. So actually, the area of the second frame is going to be exactly the same as, so we're going to put answer A, the same as the area of the first frame, because the 3's cancel each other out. And my algebraic statement proves that. The next question is similar to something that was on the unit 17. And students had a little bit of difficulty with this because in order to solve this, you have to understand that angles subtended by the same arc are equal. So because this arc connects those two angles, that tells me that Y and Z are going to be equal angles. Angles in the same segment are equal. Angles subtended by the same arc are equal. Those are two very important rules you have to memorize for the EQAO. Now, if I just focus on this triangle here, well, I know that a triangle has to add up to 180 degrees. So if I know that y plus z plus 44 has to be equal to 180 degrees, and y and z are equal, I can also say that y plus y, because they're equal, is equal to, sorry, made a little mistake there, plus 44 is equal to 180 degrees. So that means that 2y is going to be equal to 180 minus 44. Let me give you a second to make that calculation. So that should have given you 2y is going to give you 136 degrees. Now we solve for y by dividing by 2. And you'll find that y is equal to 68 degrees. That also means because z and y have to be equal, they're in the same segment and they're subtended by the same arc. So z also has to be equal to 68 degrees. So that leaves x. Now, by this z pattern, I know that x and z and y have to be equal. Also, with angles in the same segment, angles subtended by the same arc. So my only possible answer is C. X, Y, and Z are all 68 degrees. Okay, we have a measurement problem here, one of my favorites. The dimensions of a silo are given. I have the total height. I have in the cylindrical portion, I can see what looks like the hypotenuse because we can see a 90-degree angle right here. So they're creating a 90-degree angle. And we have to find the value that is closest to the total height of the silo. The hint is to use the side length relationship for right angle triangles. Okay. I am told that from the radius to the center, sorry, of the cylinder to the outer end, so kind of the radius, this side length is going to be equal to 8. So that means if I'm solving for the hypotenuse of the right angle triangle, this side length is also equal to 8. Now, I cannot, if I want to solve for the total height, that means I'm solving for this side length. So I have to, which I'm going to represent by the letter x. So I have to use the Pythagorean theorem very carefully. I can't substitute 8 and 12 for a squared and plus b squared because if I write this down, c squared actually represents the hypotenuse. And in this particular case, if we're talking about the right angle triangle over here, 12 is the hypotenuse. So I have to substitute 12 squared to find the height of this portion, the part from 20 to the top of the silo. I have to solve for x. So I have x squared plus the other side length that I know, plus 8 squared, is going to complete my Pythagorean relationship, the side length relationship for right angle triangles. So 144 is going to be equal to x squared plus 8 squared is 64. 144 minus 64 is going to be equal to x squared. That means that 80 is equal to x squared. But I'm not interested in x squared. I'm interested in x. So I have to take the square root of 80. And the square root of 80 is approximately equal to 8.9. It is equal to x. Now you'll notice that the answers do not have an 8.9 because we're looking for the total height. So that means I have to take this height of 20 meters and add a height of 8.9, or we can round that up to 9 meters. And that will give me my answer of approximately 29 meters.